Okay, so I think you're getting a pretty good handle on concave mirrors, or I hope you are. A few points to remember is that if the DI in that mirrors is that in front of the mirror is positive and behind the mirror is negative, and really what we mean by that is in front of the mirror is your real images and behind the mirror are your virtual. So when we say positive DIs and back here negative DIs, okay? So if you get a DI that's negative, it means the image is virtual. Because I'm doing it the way the book does it, if you get an HI that's negative or a magnification that's negative, it means the image is inverted. Really the way I've learned it and the way that I would like to teach it, but the book will screw you up then, is whenever it's negative, it's virtual. I take the negative off the magnification equation. And so then a negative magnification would mean it was virtual and erect, but the book does it opposite. So I'm trying to not screw you up with the book, but I don't like it. Okay, so those are concave mirrors. It's now time to look at convex mirrors. Okay, and I think this is Roman numeral number 2, so it's 1B2, I believe. Convex mirrors. And we had said the other day a convex mirror bulges in the opposite direction. So the reflected surface is this side. And the F and the C are back here, so they're on the virtual side. So whenever you have a convex mirror, the F is going to be negative. Okay, so this is the reflecting side here. And because of that, our images are going to be, or our rays that we're going to use are going to be a little bit different. First, remember the parallel light rays we had coming in for our concave mirror. Well, if we have parallel light rays coming in now, so coming in parallel to the principal axis, obviously they can't go through F because F's back here, but they're going to reflect in such a way that they look like they're passing through F on the other side of the mirror, that if you were to follow the reflected ray back, and I'm cheating here and figuring out, if you follow it back, it will look like it's coming from F. So they look like they're converging at F, but really, if you look out here, they're diverging, right? So a ray coming in parallel to the principal axis will get reflected in such a way that it appears to be coming from F on the other side of the mirror, and that means it's going to go out like this. So all of these rays then are diverging, and because of that, convex mirrors are called diverging mirrors, whereas the concave ones were called converging because the light rays going in parallel to the principal axis actually did converge at F. Okay, when we look at the rays that we can use, when we look at the rays used to locate an image, there's 3, but one of them is really almost impossible. So I'm going to say there's 2. Okay, so I drew it the wrong way. Shoot. That side. Oh, wait, I might have room down here. Okay, so here it is. Here's F, here's C, here's my object. Okay, so one ray we already saw. Whoops. Here's F, here's C. One ray we already saw. It's a ray that's going in parallel to the principal axis, gets reflected so that it looks like it's coming from F. And I usually draw my rays that are on the virtual side as broken lines to remind me, and hopefully you, that they're not really there. We're just as our eye follows it back and thinks it's going through this, but it isn't really. Okay, so the first ray then is a ray going in parallel to the principal axis, reflects in such a way that it appears to be coming from F on the opposite side of the mirror. My broken line didn't look like broken, okay? So a ray going in parallel to the principal axis reflects in such a way that it appears to be coming from F on the opposite side of the mirror. I'm looking for a red pen, okay? The second one is a ray that goes in through C, or appears to go in through C, still passes unreflected. So if I send a ray in, like, oh, I need to do it from this one, don't I? So I'm going to send this ray in. Pretty weak. And if I follow it this way, whoops, and tilt it just a little, it'll look like it's passing through C back here. And that means it must be hitting the mirror perpendicular, and it will come straight back out. Okay, where the two of them cross is where the image will be. So my image, where the two reflected rays cross, so my image would be here on the virtual side. The third one from the other lens, or other mirror, was a ray that appears to go in through F, and comes out parallel. But the reason that's hard is, so it appears to go in through F, you have to follow the reflected ray back, or the incoming ray through to see if it'll go through F, but then it reflects off at this point. It's confusing. Where it hits the mirror, it comes off parallel, and people always screw it up. So I would say for convex mirrors, just use these two rays, okay? Now, the good news is there is only one case with convex mirrors, okay? So one case with convex mirrors, not 5 like the other one. And so the one case, draw your mirror, draw your principal axis. The reason there's only one case is the only option is the object can be in front of the mirror. The object can never be between C and F, beyond C, right? Like they're back here. All right, so draw your object with one color coming from the top, go in parallel to the principal axis, and reflect off in such a way that it appears to be coming from F. Sound effects always help. Okay? And then with the same color, from the same spot on the top, go in so that it looks like it's going to pass through C on the other side. And so it will get reflected back. All right, do the same thing from the bottom. A ray going in parallel to the principal axis should reflect off in such a way that it looks like it's coming from F when you, whoops, this is actually solid. Looks like it's coming from F when you follow it back on the opposite side. And then again, a ray going in through C is going to reflect straight back. Where they cross, where my purple cross, this will be my head. Where my black cross, it should be about there, this will be my feet. Look at this little guy. Image is virtual, smaller, erect, and behind mirror. Okay, one case, and that's it. So for diverging mirrors, when you're doing the math, the F will always be negative. Whether they put it on in the question or not, I might just tell you a diverging mirror of focal length 6 centimeters. You need to say, that means F is equal to -6, and you need to put the negative on. Sometimes the textbook is nice enough to give it to you, sometimes not. Sometimes I'm nice enough to give it to you, sometimes not. So you need to know. Okay? One last thing with mirrors, and then when I see you for real, we'll start images. So